in the last year, and you know it, we had quite huge bark beetle infestations. We had severe drought calamities, mainly on spruce, but on other tree species as well. And there's always the call, hyperspectral can solve the problem of early detection, especially for bark beetle, but for other diseases as well. What do you think about it?
So I wrote my PhD basically about this topic, and I still remember, during probably the first 2 months of my PhD, one of the senior scientific assistants in our group came to me and said, well, you will try and you will find out it's not working. And I said, yeah, let's try it. And after 3.5 years, I handed in my PhD thesis and I told him, yeah, you were right. And since then, I have to say, I watched a lot on this topic. I read a lot about this topic. And I think if you really go for a neutral view, if you say, I only have spectral information, it doesn't matter whether it's hyperspectral or not, I would say it's impossible to early detect bark beetle infestations. In early detection, meaning at a point where it still makes sense to detect it. There's simply no signal. Even the people who measured the leaves, really, they get a signal, they can detect it maybe, 10 and 14 days before the visual damages show up, but this is too late. So I really don't believe in it.
We tested it as well, and I would say, okay, the noise is incredibly high, so we have no chance to detect it with normal, let's say, sensors and in a, let's say, management way. But if you really look at single trees, you know exactly what's going on. You know when the infestation is. You know when the bark beetle really develops its boreholes, and you have these times. You can get earlier signals even than 2 weeks, but I agree that the normal signal is not good enough to detect this, because you have to remove all the noise, all the shadows, all the branches. You have to have the pure needle signal and a very detailed information on when the bark beetle is where in the tree.
But but then I would argue, okay, but if you need to know where the bark beetle is in order to see the signal, then you don't need to measure it anymore, because then you already know that the bark beetle is there.
Yeah, of course you have to extrapolate it into other trees and to look whether it's still working.
But I think one thing that I was just now thinking of, I remember that you also had a quite interesting study where you actually tried to do the same thing with sentinels, and it also was, let's say, very challenging or not working. But then at the same time, do you think there's a certain chance of getting towards something like this, like reducing this what you call noise, so let's maybe just call it variability in the signal? If you constrain this more by putting in other information, like for example, I think you had this nice study where you tried to include, basically drought information, local drought information into the model. So would you say that this is maybe one key, that you say okay, good spectral data, but then we need constraints?
I still believe that it is possible spectrally, but I agree with you that on a management perspective, on a large-scale perspective, we have to include other information. And this might be models of bark beetle development, which are existing. This might be wind speed and direction information. This might be definitely information on infestation on previous years and the proximity to already existing spruces, together with another information like remote sensing information, would really help. But perhaps then remote sensing information is not really needed anymore, and we have to be honest to say, okay, then perhaps the model alone is not enough. And this is not just relating to hyperspectral, but to all, let's say, remote sensing information.
Yeah, I agree, and I think this is probably can be correct. But then on the other hand side, you could say that it's quite clear that you see the dynamics of a canopy. So you see if a canopy is losing water, you see if a canopy is not that active anymore. It does have something to this spectral signal. And while this signal doesn't mean it's infested with bark beetles, you know that the tree is stressed. And if you then have additional indicators, saying, okay, there should be stress because there is drought. And then okay, there has been a bark beetle infestation in this region later. Well, then at least you can have let's say, a well-based suspicion that this might be areas that are particularly vulnerable at this moment. And I think this is also a lot more the direction we should think independently, whether it's remote sensing or whether it's whether it's hyperspectral remote sensing or multispectral remote sensing. If we want to talk about these problems or forest damages caused by bark beetles or any other infestations.